got up at dawn today. My body is not accustomed to going to sleep several hours earlier, so I was awake almost to my usual time. So that means right now I'm rather tired. I'm debating whether I should even film. Is my brain awake enough to do a reasonable job? So be warned. Now, this board, the contents on this board, presented for me for the first time a new situation, and that is that it won't be on this session, or it'll be starting on the next session. But for this board, the length of the proof of a particular proof is too long for the board. It's let me just count the number of 1, 2, 3, 4 pages. That's the longest proof so far, 4 pages. Now, I tend to get through a page of the textbook per session, roughly. So 2 squares, 1 session per page. Oh, it's more like I do about 5 pages per. Yeah, it's more like 5 pages per session. Now, this proof, which is 4 pages long, starts in the last quarter of the next session. So it goes on longer than the board. Now, some of this material that I'm filming on, lecturing on, is new to me. So that means I have to learn it up ahead of time, usually when I'm writing out the board. And then, if I don't get it just by writing it out, usually I do, it's usually not too hard. Then once it's written up, I will read it over and until it's clear, until I get the overall picture. Now, the material of this particular proof is new to me, and because I haven't written it up to the end of the proof, I don't know how it's going to work out. It hasn't yet clicked, okay? And that's the first time that's happened for me in doing these MPC type lectures. This is getting towards the end of the 5th month that I've been doing this stuff, into the 3rd course, and this is a unique situation for me, so interesting. So how do I present the material then if I don't know, if I don't have an overview? I don't know what's coming towards the end of the proof because I haven't written it out yet. So the approach I'll take is, I'll do to you what I'm doing for myself. That is, there's a lot of preparatory material to get to the end of the proof. You need to set up a lot of details and structure, and so I'll just do that. And so it'll be like a 2-part process. It'll be a 2-board process. So you will need to do the same. You won't get it until the next board either. Although for you it doesn't really make much difference, does it? Because everything's cut up into small pieces anyway. So it's just for you it won't be so different. But for me, at my end, see, I tend to think in terms of boards, because that's the way I'm making them. It's only in the editing process that everything gets cut up into a board typically would be about 8 clips from your point of view, and you see the clip preceded by a title, usually. Theory, computation, 2, S, what will this one be? So S-T-U-V, this will be W, right? So 2W1, the next clip to 2w1 of 2w2 of 2, like that. Okay, so this the first session is finishing off the if part of our proof, which is an if and only if. And broadly speaking, what we're trying to do is to prove that there's an equivalence between a grammar, CF, context-free grammar, and an automaton, a machine. In this case, specifically, it's a non-deterministic PDA, push-down automaton. In other words, a machine with a stack. Okay, and we're in the middle of this rather long proof that these two are equivalent. In other words, they both describe the same set of languages. So if the PDA can generate, no, that's the grammar. So if the grammar can generate the language, then the equivalent non-deterministic PDA can, recognize it. Okay, we're talking about the same set of languages in that sense of equivalence. And the previous board, previous day's filming, we got as far as showing the basic idea for which way we were going first. We're going from left to right in the if and only if. So you have two arithmetic statements, P if and only if Q, P I F F Q, and Sipser wanted to do the easier one, and and it's obvious to me now that that's true. That the one we're in the moment, we're into at the moment, is definitely easier than the next one, which is will fill most of the contents of this board, these 4 sessions. And let's see. So we're going from left to right. We're going P arrow Q. And that's in fact the only if. That's the P only if Q. And what is P? So we're starting with the grammar, and we have to construct an equivalent PDA. And the idea was, and in the proof idea, the main idea was to construct a PDA that behaves like the grammar. So now what's the grammar doing? It's generating strings, right, by using substitution rules. So you start with a start symbol, and you use these substitution rules, and you, in progressive stages, or you get intermediate strings, if you like, mixed strings. The strings will be, the symbols in the strings will be a mix of terminals and variables. Okay, but you start with a variable. Now, the idea was construct a PDA, non-deterministic PDA, that behaves like a grammar, in the sense of using its stack to store temporarily the current intermediate string. Okay. Now so you have a variable at the top of the stack, and you substitute that variable with whatever's you substitute with the right hand side of the rule that you're using, the substitution rule that you're using, whose left-hand side is the same as that variable at the top of the stack. Now you may have several rules whose left-hand side is equal to the variable at the top of the stack. When that happens, you split. Now it's a non-deterministic machine, okay, so you can make copies of the PDA and put one where the stack is the right hand side of one rule, and you can have another copy of the PDA where the right hand side of your rule is on the stack of your second copy of your PDA, and so on. Right? So that's the basic idea. You're creating a PDA that's behaving like a grammar, and it's using its what's the word? Its nature, because it's a PDA. It's reading input. It's an automaton. It's reading in the input string, symbol by symbol. So it has an input string, and it has a stack, and it's using those both of those facilities, or whatever you want to call them, to behave like a grammar. Right? And what do grammars do? They generate strings by using substitution rules. They substitute variables for the right-hand side of the substitution rule, and eventually you will get to a string that's entirely terminals, and then you stop because you can't go any further. You can't substitute terminal for anything. Terminal's a terminal. That's the end of the line, so to speak, for that symbol. But you can substitute a variable for something. Usually a mix of terminals and other variables. Usually. Okay, so that's the main idea of the proof of the first part, the P arrow